Alright, welcome back to Basic Electronics course. And if you've learned something so far, that is beautiful. In this video, we're going to be talking about capacitors. Now, what is a capacitor? Before we proceed, let me show you pictures of different capacitors. So, for example, this here is a capacitor. This here is capacitor. This here is a capacitor. If you look closely, you can see 105J and 400V, 400 volts. That's a capacitor there. Here, the name is faint, the numbering is faint, but I'm not sure we can capture that. Okay. It's not coming through. And here, this is another capacitor. It's another capacitor. You see 22 UF 450V. What does this thing stand for? So let's start. What is a capacitor? A capacitor is also a passive electronic component. Passive means that it does not increase or reduces the current. In most cases, it reduces the current flow. It doesn't actually increase it in many cases. So it's a passive electronic component. Second, it only has two terminals. 1, 2. Capacitors have just two terminals. Keep that in mind too. So all capacitors have two terminals. Two terminals. So what is a capacitor? As I was defining, is a passive electronic component that can store electric charges. So that means that your capacitor can act like a little battery. In simple terms, it's like a little store of energy. Like when your battery, your rechargeable battery, you can use up your rechargeable battery and charge it back. Capacitors are like that, but in a very small fraction of what the power of a battery can be. Capacitors are measured in farads. So the F you saw on this capacitor, for example, stands for farad. The F you saw here, bring it back, come on. Here you see that 22 UF. That F there stands for farad. That U there is actually for micro. Micro is times 10 raised to power minus 6. So the value of this capacitor here is 22 microfarad. That's 22 times 10 raised to power minus 6 farad. Is there a lot of capacitance? Well, it depends on the application. Depends on the application. So, and then the V there makes you know how much voltage that this capacitor can tolerate. So this is rated 450V. This is a high voltage capacitor. This is a high voltage capacitor. That means this capacitor can successfully withstand up to 450 voltage. 450 volts between its terminal. That's a dangerous capacitor there. When you are repairing, when you see such capacitors, don't just go ahead and touch the terminals. You can receive electric shock from there. Alright, there are other low voltage capacitors. Let me show you some. So I've showed you for 450 volts. Let's see if the camera can capture this. So this one I'm holding here is 16 volts. Can you see it? I'm not sure you can see it. It's so tiny. This is 470 microfarad by 16 volt capacitor. So capacitors actually comes in their capacitance, that is farad, then the amount of voltage it can withstand. Unlike resistors that limit current, capacitors does not actually limit current, uh, and it does not actually limit voltage in normal operations. But what can blow up your capacitors is if you exceed the rated voltage. Did you get that? For a resistor, if you exceed the rated current, you blow it up. For a capacitor, if you exceed the rated voltage, you will blow up the capacitor. Hope you got that. Please keep that in mind. Now, before we end this introductory video to what a capacitor is, now what are the kinds of capacitors that we have? Just like I showed you earlier, I showed you three different kinds of capacitor, and this I showed you three different kinds of capacitor. So what are the kinds and how are they different? As a beginner, I would like you to just focus on two large distribution of capacitor. The electrolytic capacitor, which is this. So most electrolytic capacitor you will see, the common ones are radial, that is they are round like this, they are just round and they come in different sizes. Then you will see that there's a terminal where they wrote that minus sign. So that's a minus sign actually. It means that's your most negative point in your circuit must connect to the minus side. The other side of the terminal is a positive side. The other side, where the minus side is on, is the negative side of this capacitor. Whenever you find a capacitor that is like this, it is electrolytic. Now, what do we mean by electrolytic capacitor? It means that polarized electrolytic capacitor, polarized capacitor. If you put the positive on the negative and the negative on the positive, you're going to blow up the capacitor rather. You're going to blow it up. So keep that in mind. Polarized electrolytic capacitor. This is polarized electrolytic capacitor. There are non-polarized electrolytic capacitors. So in that case, it may also be radial, it may not be radial, but you will see the value, you see the value, you see the voltage, but you will not see the minus sign. Are you getting me? You see the value, you see the voltage, but you will not see this minus side there. That means that you can use any side. You can connect the capacitor without minding the polarity. Alright, that being said, so these are polarized electrolytic capacitor. They are non-polarized. They are also non-polarized electrolytic capacitor. These capacitors here, they are non-electrolytic. For these two capacitors, they are non-electrolytic and they serve for other applications. So in most cases, whenever the voltage is not specified, you can check the data sheet, you can check online to see what is the voltage that is the maximum voltage that that capacitor can take. But look for this one, 105J. 105J. Now there is no exact value written on it except 105J. Let me make it, let's see if you can get it clean. Okay, good. 105J, 400 volts. What does 105J mean? That I will explain. But 400 volts means that this capacitor is rated at 400 volts. These capacitors, the capacitors that look like this are actually designed for high voltage applications. So you have them in variant of 250 volts, 400 volts, 600 volts for their rated voltage. But what does 105J means? Let me show you. So if you have a capacitor where the value is not written directly on it, like the previous 22 microfarad capacitor, and maybe it's written in quotes like this 105, 104, 103. What does it mean? So when you have capacitors like that, let's take 105 for example. Let's take 105 for example. 105, 105. 105, 105G. You have capacitor that its value is this, is written as this. If you check the internet, or let me just explain. So this is coding. I mean a coding system for capacitor. The first two values here is an idea of the capacitance. This one is the multiplier. So let me write it out so you can see. This here is measures the capacitance, the capacitance you get. Are you following? This one is a multiplier. and this J here is a tolerance. From resistor color code, I believe you should still be able to remember tolerance and this color notation, this um, numbering notation. So if you want to know the capacitance of this capacitor, it will be this 10, 1 0, then add 5 zeros to it, 4, 5, 5. Then the value of the capacitance is a picofarad. Pico is Pico stands for times 10 is for our minus 12. Times 10 is for our minus 12. If you want to convert this value to microfarad, just count from this end, count 6 steps backward. So from here, that will be 1, 2, 3, 4, 5, 6. So this is equivalent to a 1 microfarad capacitor. 1 microfarad capacitor. Hope you got that. Let's do one more example. Say you have 472. You have a capacitor. Oh, I didn't mention the J. What does the J stands for? This J stands for the tolerance, and J is equivalent to 5% tolerance. J is equivalent to 5% tolerance. Okay, having said that, let's take another example. If you have 472, if you have 472 J, what will be the capacitance? Remember 47, it will be 47, then you have two zeros, then the value is in picofarad. If you want to convert this to microfarad, you count 6 steps backward. So from this point, 1, 2, 3, 4, that's 0.4, 5, 0.04, 6, 0.004. So that will be 0.0047 microfarad. Do you get that? So that's how the numbering for capacitors are widely handled. Do you understand that? Okay, in the next video, I'm going to show you uh, capacitors in parallel and capacitors in series.